Sorry about that. My phone decided it wanted to overheat and not continue to record what we were doing. So we're going to pick up where we left off in that first video. We had just said that the triangle here on the left, WZX, which we had colored in, would be congruent to this other non-colored in triangle, WXY. And we know those are going to be congruent by side, angle, side, side, angle, side. So we start there. The triangles are congruent by side, angle, side. Now because they are congruent, then WZ and WY will also be congruent to one another because they are corresponding parts of congruent triangles, so they are congruent. But we cannot use CPCTC unless we have proved those two letters right there, congruent triangles. Only because of that, then are the corresponding parts congruent. That tells us that since WZ and WY are congruent, then their lengths have to be the same. So 2x plus 11 has to be the same as 4x minus 5. That allows us to write down our equation that we can then solve for x. So we have like terms on different sides of the equal sign. I'm going to choose to move the 2x. 2x minus 2x is 0. Then we have 11. 4x minus 2x is 2x. Bring down the minus 5. To get x alone, we need to move the minus 5, so we'll do its opposite. 11 plus 5 is 16. Bring down the 2x. Negative 5 plus 5 is 0. That goes away. We're going to divide both sides by 2, and we get x having a value of 8. Now this question didn't ask it, but we could most certainly plug the 8 in to each of these two expressions, and we should get the same answer on each of them since we know they are supposed to be equal. Page 2 of our notes has us following 3 steps. First, prove that the triangles are congruent. That has to be our first step. We can't move on to CPCTC or anything else until we have proved that the triangles are congruent. That has to be our number one top priority first step. Then we're going to use CPCTC. So remember, corresponding parts of congruent triangles are congruent. And we're going to use that to find the missing value, and we are supposed to show your reasoning. So we're not going to write out like a full-fledged proof per se, but we are going to make sure that we follow those steps and show our reasoning. So the first example we have is triangle ABC, and we can see we have this segment AD right here coming down as a perpendicular bisector. I know it's a perpendicular bisector because I have a 6 marked on BD and a 6 marked on CD. So since those are the same, I'm going to mark them accordingly. And then we have a shared side right here by a reflexive property will be congruent to itself. AD is congruent to AD. So now we have 3 things marked: a side, an angle, a side, an angle, a side. It is the angle that's between those two sides. So triangle ABD will be congruent to triangle. Now I have to be careful. I can write that first one in whatever order I want, but my second one has to match. So I did ABD. I need to do ACD. And those are congruent by side, angle, side. And yes, I have to say which postulate it is that has them congruent. Now, the question itself asked for the length of AB. AB is here. It's the first 2 letters of our triangle statement there. And so AC, the first 2 letters, are the ones that will correspond. So AB will be congruent to AC by corresponding parts of congruent triangles are congruent, CPCTC. So if AC is marked as 9, then I know that AB would have the same measure. So AB has a length of 9. Now when I name them to say that they're congruent, I use the segment symbol over top. To differentiate when I'm giving a measure, instead of just naming it, I no longer put that segment symbol over the top. I just say AB without the line, and that's how I know I'm giving a measure, and it's 9. Now your temptation is going to be to skip to this. I know that, but we have to follow our directions. We don't know that AB is 9 unless we know that those 2 triangles are congruent to one another. So you have to start and follow through the appropriate 3 steps, and yes, you have to do that on your homework as well. You have to tell the triangles are congruent by which postulate, say which pieces need to be congruent by CP/CTC, and then tell the actual measure. All right, let's move on to number 2. So what we have marked in number 2 is a right angle, so therefore I know this one would be a right angle. And I have this length of 7 and this length of 7. I also know that FH will be congruent to itself by the reflexive property. And now I have 3 things marked, an angle, a side, and a side. Now that, if I were to just label it, would be a bad word, so I know I can't use that one as a congruence postulate. But I see a right angle and a hypotenuse and a leg, a right angle, a hypotenuse, and a leg. So we are going to say that triangle HEF, and again you could put that one in whatever order you want, but now the second one you have to pay attention. So I did H first, so I need H first. Then I did E, that corresponds with G, and then F. And we said that one was by hypotenuse leg. The question itself asks for the length of EG, which is this entire distance. So I know EH is 3, which means HG will also be 3, because those are going to be corresponding parts. So I need to list that. So EH, which if you look at it for me is the first 2 letters, so HG, first 2 letters. Remember, they should be in the same placements. So those 2 are congruent by corresponding parts of congruent triangles are congruent. That in and of itself tells me that HG has a length of 3. Now I'm going to use segment addition postulate because it asks for EG, which is that entire distance, so 3 plus 3. So EG will have a length of 6. Segment addition postulate just tells us that we can add those 2 lengths together to get the length of the entire segment. Number 3's setup is very similar based on what's marked. Now these X's down here don't really help me, they're just expressions. I need to know what the actual values I have. So I've got a 10 and a 10 marked, another right angle, and another shared side. To figure out which one we're going to use to say that these triangles are congruent, let's look. We have an angle, a side, and a side. That's a bad word. So the side that's marked is the hypotenuse, and then we have that joint leg. So this is going to be hypotenuse leg. The first triangle we can name in whichever order we want. So let's see, SRU is congruent to triangle. Now because I did S first, I have to do T first, then R, and then U by hypotenuse leg. Now what I want to be able to find is the value of X, and eventually I want to find this length of SU. That's what it asked me for up here. So this length right here is what I will need. Now SU, which is what I'm looking for, will be congruent to UT. I can see that they are corresponding. So SU will be congruent to TU or UT, it doesn't really matter, by corresponding parts of congruent triangles are congruent. So I know that SU's length, which is 2x plus 2, will have to be exactly the same as TU's length, which is 3x. So I can solve that equation by subtracting 2x. 2x minus 2x is 0, so I bring down the 2. And 3x minus 2x is just x. So x has a value of 2, but the directions said to find the length of SU. So SU's length was 2x plus 2, and we know x is 2. So 2 times 2 plus 2. That'd be 4 plus 2. So SU has a length of 6. Now our next example asks us to find the measure of an angle. So it's a little bit different, but it's still the same idea. So we're starting with 2 triangles. We can see we have right angles marked, and we have these 2 lengths marked as CD and BD. We also know that AD will be congruent to itself by the reflexive property. So we know that triangle ACD would be congruent to triangle, so I did the top one, ACD, so I need to do ABD by, so let's take a look, right angle, side, side, so angle, side, side, again that's a bad word. AD is the hypotenuse for both the top triangle and the bottom triangle. BD and CD are the legs, so this is hypotenuse leg. Therefore, now we'll look what we're looking for. Angle CAB. CAB. Oh, that's that whole angle, all of it. So what I have already is that this piece of it is 20 degrees. And because these are corresponding, that means this one up here will also be 20 degrees. So let's name that. Angle CAD will be congruent to angle BAD because corresponding parts of congruent triangles are congruent. So that means I can write a little 20 degrees right there. That tells me that the measure of angle CAD is 20 degrees. Now by the angle addition postulate, I can add those 20s together and find out that the measure of angle CAB is 40 degrees. Yes, I know, most of you could have just looked at that and said, oh, it's going to be 40, but you have to indicate why it's 40 degrees. Don't hesitate and don't think you're going to take a shortcut. Do your triangle congruence, do your CP/CTC, and then give the measure at the end. The next question asks for the length of DC, so just in case you wanted to know where we're headed with this one. We have 90-degree angles marked. We have a 30 degrees here and a 30 degrees here. And then we have the shared side by reflexive property of AD is congruent to AD. So we're going to start with triangles. Triangle ABD is congruent to triangle ACD. And I just wanted to make sure to put that 90-degree angle in the middle, just like I had over here, by... So we have an angle, and a side, and it is not the side that touches both of the angles. That would be AC over here. So this is going to be angle, side. Notice the side is not in the middle. And we're looking for DC, so DC will be congruent to, DC is the last two letters, so BD is the last two letters, by corresponding parts of congruent triangles are congruent. Therefore, DC will have a measure of 5 since BD had a measure of 5. And our last example in this section, again, we have a 90-degree angle, a 90-degree angle. We have angle A and angle A marked as congruent. We know we have this shared side as reflexive property. So triangle, I'm going to do this left side. Let's see, ABD is congruent to triangle ACD, and that's by, let's see, we have an angle aside. This side is the two that would touch the angle, so it's not angle side angle, but rather angle side. And we're supposed to find the length of BD, so what would BD correspond with? BD will be congruent to last two letters, CD, because corresponding parts of congruent triangles are congruent. So I know that BD and CD have to be the same, so they each have expressions on them. That means that 3x plus 1 has to have the same value as 5x minus 1. So we'll solve that equation. Subtract 3x on each side. That equals 0, so 1. And 2x minus 1 brought down. We're going to add our 1. So 2 is equal to 2x. We're going to divide by 2, and we get x having a value of 1. Now this is the value of x, but the question was, what's the length of BD? So we need to take BD, which is 3x plus 1, and plug in the appropriate value for x. So 3 times 1 is 3, and 3 plus 1 is 4. So BD has a length of 4. Now the last two questions on here are going to ask us, working backwards, can you prove something? Can you prove that AD is a perpendicular bisector? So let's take a look. Well, I can see AD right here. It is perpendicular. I know it's perpendicular because it has the right angle. So I can prove that part. Oops, wrong part. I can prove it's perpendicular. The question is, can I prove it is a bisector? If it's going to be a bisector, then BD and CD would have to be the same. So the question is, are they? Well, I've got two triangles. I've got a shared side here. Can I prove that these two triangles are congruent? I have a right angle, a side, and a shared side. That's a bad word, but AB and AC are the hypotenuse of their individual triangles, so I think I can use hypotenuse leg. I believe triangle ABD is congruent to triangle ACD because we have a hypotenuse and a leg, a hypotenuse and a leg. Well, if those are congruent, then BD would be congruent to DC because corresponding parts of congruent triangles are congruent. So, if these two are the same, then yes, I can say that AD is a perpendicular bisector because I proved it was bisecting or cutting in half. And our very last question, can you prove AP is an angle bisector? So here's AP. If it's going to be an angle bisector, it's going to have to cut this angle in half up here. So in other words, if this is 30, then this one would need to be 30, but we don't know that. That's what we're trying to figure out. So let's take a look at what we have. We have a 60-degree angle right here, a 90-degree angle here, 30 degrees, and that shared side of reflexive property. Now in this triangle, I know a lot. I know all three angles, and I know a side. But when I look at this triangle over here, remember I don't know, let me erase that marking, I don't know anything about this angle. I want it to be 30, but I don't know anything about it. All I know is a right angle and one side. So I don't have enough information in this triangle. I only have two things. Everything that's going to prove congruence requires three pieces of information. So my answer over here is no, I can't prove it. Why? I can't prove it because I can't prove the triangles are congruent. So if I could prove the triangles were congruent, then yes, maybe I could work to AP being an angle bisector, but without the triangles being congruent, I can't move forward in any way, shape, or form and assume anything. Make sure you follow through your steps today. Don't hesitate to contact me if you have any questions at all.